I've started to replace the components on the board, and I thought I'd take a moment to show you the technique I'm using. So I'll take out this big guy right in the middle here. Now you may notice that all these capacitors have colored stripes on them. If you're not sure how to read these, well, one, you could look on parts locator. This is out of Sam's, and they've got an arrow pointing to this. It says it's C36. If we look on the parts list, we can find C36, and it's 0.1 microfarad, 400 volt. Well, they're actually pretty easy to read. I'll turn this around here, and it's actually the same color code that resistors use, and the value will be in picofarads. So we have brown, black, yellow. That's 1, 0, and then the third band is the multiplier. Yellow is 4, so 4 zeros. So that's 100,000 picofarads, or 0.1 microfarad. As for the voltage, that's what the last band there is. Yellow, which is 4, it's a 400 volt capacitor. Now to take these out, you want to be careful so you don't damage the foil traces on the other side. The technique I like to use is cut these off so there's just, maybe 1/8 of an inch of lead left. And make sure they're straight, because what I'm going to do is heat it from the other side and push the remains of the lead down through. I've got my soldering iron turned down a bit. I think normally this can put out 65 watts max, so I've got it down to maybe the 35 or 40 watt range. Alright, so to part out, I now flip it over and figure out on the other side where it's at, and it's this one right here. So if I heat that up and let gravity help me out a little bit and poke it a little, just be careful don't burn yourself, and there we go, fell right out. Also, the hole is left open, so I don't have to worry about solder wick or solder sucker or anything. I can put the new leader right down through it. To the other one, and there we go. That's it. No damage to the foil traces. Piece of cake. Now, while I've got the part out, I like to clean up the circuit board. I cleaned this previously, but it's still a bit messy. I'm using some Spray 9 multi-purpose cleaner. Just spray a little bit on the end of a Q-tip and go over it. I've used paint thinner in the past too, and that works pretty good, especially you want to clean up flux or some other stubborn type goo. Alright, and here's my new capacitor. I got a variety of choices. I could use one of these guys, I could use one of these guys. I like to save these though for applications where you really need to use an axial type capacitor, and these do cost a bit more, so I'm just going to reserve that one and go with this guy, which really is a PC board mount style anyways, but unfortunately the old parts are so much larger that the leads, the holes are way too far apart, so I'll have to bend these leads a bit. Over a bit on the other side. This board's a little unwieldy. There's one transformer that sticks out pretty far and it causes the board to wobble around. And then I've got these cutters that are angled so you can get pretty flush to the circuit board and clip off the excess leads. Alright, I just need to do that a few more times. I'm going to do all the film caps first because that'll free up space. Because as I said, the new ones are smaller. I'll start tackling the resistors. I've been doing some research on these hybrid modules too. It seems like the recommended course of action is to for sure replace the vertical integrator, which I think is also called K5 maybe. And I think that's what this guy is. When I was working on the Philco Town and Country, it also used some of these, but they were not encased in this goo. So I was able to actually pick off individual components and replace them. Can't do that on this guy unless I can figure out how to remove this coating safely. On the bright side though, from what I've read online, of these 5 modules on here, typically you only need to replace 1, maybe 2, which is K4 and K5 I think, or maybe K3 and K4. I'm also going to be replacing the resistors, and I'm using the same technique as I used on the caps. For example, this guy right here is a 15K 1 watt resistor. I'm going to replace with the 2 watt. Notice how the modern 2 watt is actually smaller than the old 1 watt. That's because the newer metal oxide type resistors can take heat better than the old carbon type. And now I'm not even bothering to test them. I'm just going to replace all of them. It only cost a few cents. And as I keep saying, I don't want to have to service this set again. Okay, I finished replacing all the discrete resistors and capacitors on the main board. No problems so far. I've read about how these boards often have problems with traces lifting up or discolored areas from overheated components, or sockets lifting up off the traces, or having broken socket pins. And I haven't had any of those problems so far, other than there's one socket being a little bit damaged, and really the pins are alright. It's just this top wafer that broke off. Otherwise, underneath, this board is just fine. Alright, so that leaves me with one last major thing on this board, which is these guys. I've already removed the one that I've read is the most problematic, which is K4. That's used in the vertical output tube. It's sort of a feedback network. And one of the problems with it is it's got a lot of voltage on it. So that's right here in the schematic, which is confusing because there are two sections to it. There's a part shown here and a part shown here. That's actually the same module. 2 resistors, 2 capacitors in one package. So here we see there's an external capacitor with it's rated for 1,000 volts. So this capacitor, if you're going to replace it, should also be rated for 1,000 volts. So I have picked up some components for those. 2 mica caps, both rated for 1,000 volts, and a couple 1-watt resistors. Probably overkill on the resistors. Half a watt is probably fine, but what the heck, why not? But I don't know that this is bad. I've also read differing opinions online about whether you should replace all the networks, some of the networks, or none of the networks. So what I think I'm going to attempt to do is create some kind of socket so I can insert and remove these as needed. This guy only has 3 pins. It goes in right here. So if I can install some kind of little plugs on the board here, then I can just stick this right in. Like, imagine like a transistor socket or an integrated circuit socket. So like if I take a 3-pin transistor socket and break it up to get the pins out and solder them in here, I could perhaps just plug one of these in, and if this doesn't work out alright, I can build my own and replace it. Same goes for the other modules. Now you might be thinking, why don't you just test these? Well, you can and can't. It kind of depends on the module. This one, I think you possibly can. Let's see. Yeah, this one I should be able to test completely. So between pins 1 and 4, I should measure 33K. Between pins 3 and 4, I should have 150K. So that's for the resistors anyways. The capacitors, well, if you try to measure this capacitor, you've got a resistor in parallel with it. So of course it's going to be leaky. So, and likewise when you try to measure the capacitance, you're not going to get a correct reading. This guy though you could check, because there's nothing in parallel with it. So this, and this, I think this is probably the most likely one that has problems, because it has the high voltage pulse on it. So yeah, I'll get out my multimeter, and for the heck of it I'll check these 2 resistances and I'll check that capacitor and see what I get. But regardless, I do want to plan for a worst case scenario where these modules need to be replaced and I can't fully test them. So I'm going to dig around and see what I can come up with. This is the next most likely, most suspect module I've read about. That's the one that has the vertical integrator network in it, which is K3. Also only has 3 pins. There we go. But also even more difficult to test, because it's got that funky capacitor that's sort of wrapped around a resistor. And then likewise here we got a resistor and capacitor and parallel, so you can't really measure those. You can't, well, you can kind of measure this resistance. If you go from pin 1 to pin 2, you should get 43K. but that could be misleading because all you're measuring is the combination of these two, one of which could be too high and the other one's too low, and you wouldn't quite know it. At any rate, that seems to be the biggest hassle working on these sets, is these modules, because you can't test them very easily. Really, the only way to properly test them is in a functioning set, and if there is a problem, you got to pull the board back out to check on them. So I would very much like to make these removable if at all possible. Okay, let's check this module. So between pins 1 and 4 we should have 33K. It's 2 outside pins. Nice of them to put the numbers right here in the package. So 1 to 4. Yeah, it's pretty far off. About 45K should be 33K. And between pins 3 and 4 it should be 150K. 189 I mean 183 basically. It's the same thing I found with the Philco Town and Country. In spite of what at the time was advanced packaging technology, all these resistors I've ever checked inside these packages measure high. Just as high as the carbon resistors, which makes me think that inside this package they're just plain old carbon composition resistors just encased in this material, and they drift as high just as often as regular guys like these. So I'm even more inclined to replace them. I'm also going to try popping out 1 or 2 others. Now, just because they're high doesn't mean it's not going to work. I mean, it's not like they're horribly off. They're like 20-something% high. I'm actually a little more concerned about these other modules. These are used in sync separator and horizontal oscillator circuits, horizontal AFC rather. And that stuff can be a little more touchy about values drifting out of tolerance. Now I thought I was going to be able to measure this capacitor with a capacitance bridge to see if it's any good, but I was wrong. SAM schematics are very confusing when they break this network into 2 separate sections on the schematic. If you combine those sections into one network, this is how it's really connected. So yeah, there's a cap between pin 1 and 3, but if we follow this up to the 33K resistor, come back down and around to the 150K resistor, is actually a resistance of around 183K in parallel with that capacitance. So if you try to measure the leakage, you're going to have leakage, of course, because it's going through the resistors, so I really can't measure that. So again, all we know for sure is the resistance is too high a bit, but that doesn't mean that it wouldn't work. Only one way to know for 100% sure, and that's to try it in a circuit.